Hello everyone, welcome back to ptet.chemistry channel. So this is the start of a year 10 curriculum for the combined science, or well, in many other countries they just simply call it combined science. Basically the three natural sciences combined into one subject, which is more of an elementary or foundation level kind of chemistry contents. Okay, so here I'll be talking about chemical reactions, the start of this big topic, one of which is on physical and chemical changes. So stated in the curriculum, candidates should be able to identify. So they just need to be able to state what is physical change and what is chemical change, and what is the big differences between them. So there are two bits to this syllabus. First of all, what is physical, what is chemical change, and the other one, what is the difference between these two different chemical changes. From the name itself, chemical changes means there is a change to chemical composition. Composition means what are you made up of. So when chemical reactions happen, your chemical identities would have changed, and therefore there is a breaking of old bonds and there's a formation of new compounds or new substances. Whereas when you have physical changes means they just change physically, but chemically is still the same. So what we say is chemically unchanged, because it is just physical changes. So the appearance, how it looks like, might change. However, the chemical composition, what you are made up of, is still exactly the same, because physical changes are basically very simple things, such as changes of physical state, all those things from states of matter back in year 9 at the very elementary level, solid to liquid, which is melting, liquid to gas, which is boiling, and so on and so forth. Change of state is always physical change. Whereas when you get chemical reactions, that is mostly what chemistry is about. There's chemical change there. Just a brief table outlining the main differences between physical and chemical change. Reversible means you can go backwards, you can reverse it. Changes of state, just like your ice, like ice can melt to liquid water, and then the water, if you put it back in the freezer, it can go back to ice. So that is why physical change, such as a change of state, sort of what I have exemplified using water and ice, so it's reversible, you can go back and forth. But then chemical change is not reversible. Once you undergo a chemical reaction, it's quite hard to go backward. In terms of identity, you don't form any new substances, whereas chemical change, because you undergo a chemical reaction, you can form one or more new substances. Chemical properties, because you are not changing the chemical identity, so they keep their own chemical properties. Chemically, they remain unchanged. Physically, how they look like might have changed, but chemically it's still the same property because it's still the same substance. Whereas chemical change will bring about new substances being formed, and therefore they can have different properties from your original substance. These are just various examples. These are not everything that you are supposed to know, obviously, but then these are the changes of state from your year 9 kinetic particle theory, old states of matter topic. All of these are physical changes. When you mix substance together, I'm sure you remember this idea on atomic structure, where we were asked to differentiate from diagrams how to tell that it's a mixture of elements. Mixture of element and compound, mixture of compound and compound. By looking at diagram, you should be able to identify that mixing substances together is just physical change, because they are just mixing substances together. They retain or they keep their own original chemical properties. Most of the reactions that we learn in chemistry, so all of these neutralization, which is basically acid plus base, or acid plus alkali. This was stated in the year 9 chemical reactions under reacting masses, as well as chemical formula, when I covered through this particular topic back then. Metal and water, metal and acid, these two reactions, they were also covered back then. This one will give you metal hydroxide and also hydrogen gas. Hydrogen gas exists as H2 molecule. That was also covered in that particular series of lecture tutorials. Carbonate and acid give you metal salt, and then carbon dioxide, which is CO2, as well as H2O. Ammonium salt, ammonium ions, as you know, is NH4+. This was covered in the year 9 chemical formula, the list of tables of ions that you are supposed to be able to identify, and so on and so forth. but these are just the general reactions that you're supposed to know from your Year 9 chemistry under combined science, under the foundation science tier after all. Now just to go through a couple of questions, just to reinforce the idea, which one represents a chemical change? Remember that chemical change is not a physical change. You must form new substance. So you form new substances or new substance. So there's a change in chemical identity. Here in option B, you can see the molecule. These are molecule because there's one molecule, two atoms bonded together. There's another molecule, there's another molecule. Now they are getting further apart. So they are just getting further apart. There's just change of state where you are just moving the molecules further apart. Change of state is physical change. Here, instead of moving apart, you're just bringing them close together. These are what you call tightly packed and tightly packed particles. So the particles are tightly packed. That is going to be your solid. This one with a little bit of space in between, the particles can slide past each other. There's going to be a liquid particle, whereas gaseous particles are going to be very far apart, moving at very high speed. This is again change of state. This is also physical change. If you look at option C, what has happened is, well, you have this black stuff, which are molecule. So that thing is molecule. And then what happened on the right hand side? These are still molecule. So these are still molecule and they are the exact same molecule. Black and black, black and black. Two or more atoms bonded together is what you call molecule. The black and the gray, however, is what you call atoms. So they exist as single atoms, just like your noble gases. That is still atom and this is still atom. What has happened is the molecules and the atoms are just getting further apart. This is again physical change, which means our only answer must be option D. And there's a change in chemical identity. If you look at these two black atoms, and now you only have one black atom and one gray atom. So something has changed. So there's a change in identity. There's a change in chemical composition. When you write the word composition, it means what are you made up of, okay? So change in chemical composition, change in chemical identity, there's going to be a chemical change there. Question 2, which row identifies a chemical and also a physical change? So there were a couple examples that I given you in that table just a couple of moments ago. So this is boiling. Boiling is to do with physical change because that is to do with change of state. So change of state, as you know, all the terms that were stated in the syllabus, freezing, boiling, condensation, sublimation, what else, melting, they are all to do with change of state. So that cannot be chemical because that is what the question said, chemical change there. So A and D are out. And what we're looking at, physical change, evaporating ethanol, yes. Burning, burning is combustion. So we talk about combustion being the burning of a compound. Therefore, combustion is chemical change. So combustion is not a physical change. So, that cannot be for physical change there, which means C cannot be the answer. B must be the answer. As I said, burning ethanol, which is combustion. So combustion of a substance is actually a chemical change. In this case, it gives you carbon dioxide and water. Here is just the ethanol liquid turning into ethanol gas because evaporation or boiling is to do with change of state. So here we know evaporation can take place at any temperature. And in this case, it's not at the boiling point because it's evaporation. If it is boiling, then it only takes place at the boiling point. That's it really for these short lecture tutorials on identifying chemical and physical changes, and I've shown you with 2 questions what kind of things could be asked. So very direct, very straightforward there. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel and follow me at ptet.chemistry across all the popular social media platforms. Thank you for watching.